In this video, I'm going to solve problem number 3 of Laplace equation. In this problem, a potential field V is given, and we have to prove that del square V equal to 0. Also, we have to find the constants A and B in the equation of V for the given values of V and E at a specified point. R and phi are the variables available in cylindrical coordinate system as well as spherical coordinate system. But if you observe carefully the point of interest, it contains only one angle. So the problem is in cylindrical coordinate system. R, phi, z. So we have to prove that del square V equal to 0 in cylindrical coordinate system. Let us start. So del square V is expanded as 1 by R, dou by dou R into dou V by dou R. The first term of the expansion. Second one is 1 by R square, dou square V by dou phi square plus dou square V by dou z square. You can observe two differentiations in each term. First one with R, second with phi, third one with z. But the equation of V contains only R and phi. Here you can observe it. No z is present. That means potential V is not a function of z. So dou square by dou z square is 0. So in the next step, we have to substitute the given potential field into the equation of del square V. Here, R into, we shall copy that equation, A into R power 4 plus B into R power minus 4 into sine 4 phi. But here, differentiation is there. One by R, dou by dou R, dou by dou R of the given V. Next, the second term plus 1 by R square, dou square by dou phi square of same V. A R power 4 plus B into R power 4 into sine of 4 phi. No unit vector because del square V is a scalar function. Now the differentiation 1 by R dou by dou R into R So we have to differentiate the function v with respect to r. So therefore, first term, differentiation of r power 4 is 4r cube. So 4r cube. Similarly, differentiation of r power minus 4 is minus 4. R power minus 4 minus 1 is minus 5. Sine 4 phi is constant because the differentiation is with respect to r. The second term, one differentiation is written and we'll perform first differentiation, that is with respect to phi. So r terms remain same, no change. Differentiation of sine is cos 4 phi into differentiation of 4 phi is 4. So we should go for one more differentiation. Before that, I would like to simplify the term to be differentiated. Here, multiply the term within the bracket by r. So that gives us a 4a r cube into r power 4 again, minus 4b r power minus 5 into r power 1. So it's again going to be r power minus 4 into sine 4 phi. In the second term also, let us see what happens. 4 is there. We can multiply constants a and b by this 4, so that we get 4a r power 4 plus 4b r power minus 4 into cos 4 phi. Okay. So what happens in the next step? Here is another differentiation left with respect to r and here with respect to phi. So first one, 1 by r, differentiation with respect to r. So what happens? R power 4 is 4r cube. So 4 into 4, 16 a r cube. Similarly, this is minus 4 r power minus 5. So minus into minus plus 16b r power minus 5 into sine 4 phi constant plus the second term to be differentiated with respect to phi. So 4a r power 4 plus 4b r power minus 4 are kept as they are because they are constants. With respect to phi, we have to differentiate cos. So we know that differentiation of cos is minus sine. So minus sine 4 phi. Differentiation of 4 phi is 4. This is the complete differentiation. Let us see whether we get 0 or not. Here, multiplication of the first term by 1 by r gives us 16a. R cube divided by r is r square plus 16b. R power minus 5 divided by r is r power minus 6. Into sine 4 5. This makes the first term. Similarly, in the second term, see here carefully, it is minus. I'll take out minus here and multiply the second term by r square, sorry, 1 by r square. Then we get, and also at the same time, I would like to include 4 into this term within the bracket. So 4 into 4, 16 here. 16 here. R power 4 divided by r square is r square. Similarly, 16b r power minus 6 into sine 4 phi. So the first term, this one, the second term, both are exactly same. One with opposite polarity, plus and minus, so they get cancelled out. So this makes del square V equal to 0. So the given potential function satisfies the Laplace equation. Hence the proof. Let me go to part 2 of the problem. Here V is given as under roots and magnitude of E is given 500 volts per meter. So we have to find the constants A and B. What are these A and B? These are the constants present in the given potential field. That is A into R power 4 plus B into R power minus 4 into sine 4 phi. This is the problem. So in this V function, A and B are there. So you have to find these values for given values of V and E. Let us start. Now, let us use this first value given, V equal to 100 volts. Okay. Let me call this equation 1 time being. We shall apply this 100 volts to this equation at a given point, and also the point is given. Careful. It is mentioned that these two values are applicable at point P. That is 1 comma 22.5 degree comma 2. Here 1 is R, 22.5 degrees phi, 2 is Z. So at this coordinates of the point, V is equal to 100 volts and magnitude of E is 500 volts per meter. So therefore, here I'm going to put V value as 100 by utilizing these coordinates of this point. That is A, R value in the problem point is 1, R is here also 1, into sine of 4, 5. 4 into 22.5 degree. 4 into 22.5 degree is equal to 90 degree. So sine 90 is 1. 1 power 4 is 1. 1 power minus 4 is also 1. So therefore, this equation becomes 100 equal to A plus B. I got a simple relation with the first value given. I'm going to use the second value given in the same way. That is magnitude of E equal to 500 volts per meter at the point P. So to use this value, we have to find E first. We know that E is equal to minus del V. This problem is in cylindrical coordinate system. Therefore, the expansion of gradient is dou V by dou R A cap R minus 1 by R dou V by dou phi A cap phi. Anyhow, dou V by dou Z is not required as the potential function is not varying with respect to Z. Just have written it for our convenience. Now, I would like to differentiate V first to get E. So what is E given? A into R power 4 plus B into R power minus 4 sine 4 phi. This is what is given as P minus 1 by R dou by dou phi of again V is A into R power 4 plus B into R power minus 4 sine 4 phi. This is the phi component. The phi component A cap phi, the component is 0. Now let us differentiate this first term with respect to R. So R power 4 4A R cube minus 4B R power minus 5 into sine 4 phi, which is constant, no change, minus 1 by R. Second one is with respect to phi. So R terms do not change, only sine phi. Differentiation of sine is cos. Cos 4 phi. Differentiation of 4 phi is 4. Into A cap phi. So E becomes simplified. Yeah. The first part, everything is in proper form. No change is required. But in the second part, we have to divide it by r. So therefore, a r cube, and also we'll take care of multiply by multiplying 4. So 4 you multiply with a and b, 4a r cube plus 4b r power minus 5 into cos 4 5 a cap 5. Now, further simplification is not possible. So now we are going to use the data given. So what is given here in the problem? Given that magnitude of E is equal to 500 at the point P specified, that is 22.5 degree 2. So if you want to use this value 500, we have to use the coordinates of the P. Therefore, E is equal to, let us use this coordinates, minus 4a r cube. R is 1, r cube is 1 cube, that is 1. So we get only 4a here. Next, r power minus 5 means 1 power minus 5, that is also 1. So we get here minus 4b, 4a minus 4b. Sin 4 5, as I said already in the previous step, 4 5 value 22.5 degree. 4 into 22.5 degrees, 90 degree. So sin of 90 degree is 1. Sin of 90 degree is 1. So first term is over. Similarly, let us work out in the second term. It is cos 4 5. So cos 4 into 22.5 degree. So that is 90 degree. Cos 90. So this term becomes 0. So the complete second term goes to 0. So now E is very simple mathematically. Now I can take magnitude of this E to substitute the 500. So magnitude, if I take on the right side, minus becomes plus. We have 4a minus 4b. A cap r, magnitude of unit vector is 1. So now in place of E, I can write 500, 4a minus 4b. 4 is common factor. Therefore, 500 divided by 4 is 125. That is equal to A minus B. So we have two equations here. One is the recent one, A minus B is equal to 125. Similarly, we must be having one more equation here. Equation number 2 is A plus B equal to 100. So we shall name this equation as 3. From equations 2 and 3, we get. So what happens with the 2 and 3? 200 equal to A plus B. 325 equal to A minus B. Cancelled. A 2 to 5. So, A is equal to the value of A becomes now, the value of A becomes now divided by 2, 112.5. We got A. Similarly, we shall try for B. B, what we should do, instead of adding them, we just added the terms here. We shall subtract them. A minus B, 125. First one is plus, second one is minus. If you subtract them, it becomes plus. A cancelled, 2B minus 25. So therefore, B equal to minus 12.5. So these are the values of A and B required for part B of the problem. So that's all about the problem. Thank you.